So this is the week 2 half pass paper. If you did week 1, then this is the even numbers and last week was the odd numbers. So actually those two papers make up a whole paper. 44 marks on this one. We had 36 on last week's. So together making the 80 marks that make up a whole pass paper. Let's get into it. Question 2a. Write the following numbers in order of size. Start with the smallest number. So when we're ordering numbers including negatives, we need to think about a number line. 0 is here and the negative numbers are actually smaller. So if we put these on a number line, -6 would be down here and then -5 would be here. We'd have -4, -3, -2, but we haven't got those numbers. We've got 6 that would be up here and we've got 12 that would be somewhere way up here. So in order, -6 is the smallest and then -5 and then 0 and then 6 and then 12. And always double check. I had 1, 2, 3, 4, 5 numbers in the question and I've still got 5 on my answer line. So really common mistake that people just miss one out. So there we go. Part B, write the following numbers in order of size. Start with the smallest number. So with these, we're comparing decimals. I like to write them over the top of each other. So 0.08, 0.78, 0.87, and 0.708. So lining up those decimal points. Now what a lot of students find helpful is then filling in any gaps with zeros. Just makes it a little bit easier to compare. But what we're doing is we're looking first at the ones column. They're all zeros. So I can't tell which is the biggest and which is the smallest. Then I'm looking at the tenths column and I'm looking for the smallest number, which is going to be the one with a 0 in it. So 0.078 is the first one there. The next smallest is the one with a 7, but there's 2 of those. So then we need to check the next column, and this one has an 8 in the next column, and this one has a 0 in the next column. So then we know that the next smallest is the bottom number there, because there were 2 numbers with 7s, but if we look at the next column over, the 0 told us that that one was smaller. So we had that bottom one there, and then we can put the other one, 0.78. The biggest is this number here, 0.87, because it had an 8 in the tenths column. There we go. Question number 4. Here is a list of 4 fractions: 4 over 16, 2 over 8, 15 over 60, and 3 over 9. One of these fractions is not equivalent to a quarter. Write down this fraction. Okay, so for it to be equivalent to a quarter, we would have to be able to multiply the top and multiply the bottom by the same number to get that fraction. So with this one, is a quarter equivalent to 4/16? Well, we've multiplied the top by 4 and we've also multiplied the bottom by 4. So that is equivalent. We've times the top and the bottom of the fraction by the same number, so it's kept the same. With this next one, I've multiplied the numerator, the top number, by 2, and I've multiplied the bottom number by 2. So yes, that stayed equivalent. With this next one, I've multiplied the numerator by 15 and I've multiplied the denominator by 15. So yes, that one is also equivalent. And with the last one, if it was going to be equal to a quarter, I've multiplied the numerator by 3. But that denominator, if I times it by 3, that would need to be 12. So that is not correct. So the fraction that is not equivalent is 3 over 9. Now that was only 1 mark, so you didn't actually have to show any working for that one. As long as you had 3 over 9 on the answer line and you knew that one was not the same, that got you the mark. Question 6, and we've got some algebra. Simplify 3 times 4t. 3 lots of 4t. So we can do the 3 multiplied by the 4, and our answer for that one is 12 lots of t. If I have 4 lots of t and I multiply that by 3, I then end up with 12 lots of t. Okay, for part B, I've got 8a, take away 3a, add 2a. So I'm starting with 8a. If I take away 3a, I've then got 5a. So 8a, take away 3a is 5a, and then I'm going to add the 2a, and that gives me 7a altogether. So I can do that because they all have an a. They are all like terms. So 8a minus 3a, add 2a, we can just collect them all up and then put the answer on the answer line. So there we go. Question number 8. 3 kilograms of meat costs £54. Nina buys 2 kilograms of the meat. Work out how much Nina pays. So 3 kilograms equals £54. So it's always going to be helpful to know how much is 1 kilogram going to cost me. So to go from 3 kilograms to 1 kilogram, I've divided by 3. So if I've divided the amount by 3, I also need to divide the cost by 3. So we're going to take our bus stop method or short division, whatever you call it. We're going to do 54 divided by 3. How many 3s fit into 5? Well, that fits in 1 whole time with a remainder of 2. How many times does 3 go into 24? That's 8 times. So 1 kilogram is 18 pounds. And what you could do to get 2 kilograms is you could take that off. You could do 3 kilograms, take away 1 kilogram. So you could do 54, take away 18. But I think the easiest way here is just to double it. So if I know that 1 kilogram is 18 pounds, then 2 kilograms is double that. And that's going to be 18 add 18, which is 36 pounds. Question number 10. Tim and 3 friends go on holiday together for a week. The 4 friends will share the costs of the holiday equally. Here are the costs of the holiday. £1,280 for 4 return plane tickets, that's for all of their plane tickets, £640 for the villa, and £220 for the hire of a car for the week. Work out how much Tim has to pay for his share of the costs. So that's the costs for everyone. So we're going to add that up. 1,280, add 640, add 220. You might find it easier to do it in 2 steps. 0 add 0 add 0 is 0. 8 add 4 add 2 is 14, so 4 and we carry the 1. 2 add 6 add 2, add the 1 is 11. So I'm going to put 1 and carry the 1. And then 1 add 1, I've got this one up here and this one here, is 2. So 2,140 is the total cost of the holiday. Now it's Tim and 3 friends, so there's 4 of them all together. So to work out how much Tim has to pay, we can take that 2,140 and we can share it equally between all 4 of them. So I'm going to divide it by 4. How many 4s go into 2? Well, that doesn't fit in a whole number of times, so we haven't used that 2 up. Let's carry it over. 4 into 21 goes 5 times. That's 20, so we've got 1 left over. 4 into 14 goes 3 times. That's 12, remainder 2. And 4 into 20 goes 5 times. So for Tim, he's going to have to pay £535 towards his share of the holiday. Question number 12. A shop sells desktop computers, laptops and tablets. The composite bar chart shows information about sales over the last 3 years. So a composite bar chart is one where the information for each year is stacked up on top of each other. So this bit, we know that there are 100 desktop computers sold in 2015. And then to know how many laptops are sold, that's the section with the lines, I need to start where the desktop computers ended and count up to where that bit of the bar ends. So because we were starting at 100 and going up to here, and let's just have a little look at this scale. There are 5 squares here, 1, 2, 3, 4, 5, worth 100. So if I do 100 divided by 5, that's 20. So we're going up in 20s here. So 220, 240, 260, 280, 300. So this here is 260. Oh, my pen's a bit big there. 260. So I've gone from 100 up to 260. So that's going to be 160 laptops, was it? Great. And then for tablets, it would be how much is in that top section. We know that each square is worth 20 now, so we can just go 20, 40, 60. Or you can look at the side, from 260 up to 320 is 60. So the total here, 320, is how many things were sold altogether, but we can see that they're made up of different things. Write down the number of desktop computers sold in 2015. So desktop computers, we said that was the dark black section of the bar, and we can see that that is 100. Then it says, work out the total number of laptops sold in the 3 years. So laptops is the section that is lined like this. So I need to look at all 3 years. We've already worked out that this is 160. Now we need to look at 2016. So we're starting at 120 and we're finishing up here at 340. Remember, each square is 20. So the difference between those, if we do 340, take away 120, 0 take 0 is 0, 4 take 2 is 2, and 3 take 1 is 2. So I've got 220 for that year, 160 for 2015, and then for 2017, I'm starting at 160, and I'm going up to 440. So again, let's just do a subtraction to work out how many laptops that is in between. You could just count up in 20s for each square. 0 takes 0 is 0. 4 takes 6. Now, if you're taking away, if there's more on the floor, we need to borrow from next door. So 14 takes 6 is 8, and 3 take 1 is 2. So 280. We now just need to add all of those together. 160 for 2015, add 220 for 2016, add 280 for 2017. 0 add 0 add 0 is 0. 6 add 2 add 8, well the 8 and 2 makes 10, so that's 16. Carry the 1. 1 add 2 add 1 is 6. So our answer is 660. Quite a lot of steps to that one, so well done if you got that. State the item that had the greatest increase in sales over the 3 years. Give a reason for your answer. So we can see that they all went up. They all got bigger each year, but it's the tablets, that top grey section, that proportionally increases by the most. So you want to say something like the tablets, because they more than double every year. They get much, much bigger each year. So we need to really emphasize that. So I'm going to say tablets, they more than double each year, which is way more than the other two. So that's a really clear explanation of why it is the tablets. Okay, and then Alex says in 2017, more tablets were sold than desktop computers. This means the shop makes more profit from the sale of tablets than from the sale of desktop computers. Is Alex correct? So Alex is looking at this bar here, this 2017 bar, and saying the shop must make more money from this section than they do from this section down here, okay, because they've sold way more tablets. But we don't know that for sure. The shop might make £2 every time they sell a tablet, in which case that might not be as much money as if they make £100 every time they sell a desktop computer. So we don't know what the profit is for each item, and that's why. So we don't know, as we do not know the profit for each item. You could make way more money on a desktop computer, so we don't know. Okay, question 14. Gavin, Harry and Isabel each earn the same monthly salary. Each month, Gavin saves 28% of his salary and spends the rest. Harry spends 3/4 and saves the rest. The amount of salary Isabel saves to the amount of salary that she spends is 3 to 7. Work out who saves the most of their salary each month. So Gavin, he saves 28%, which means that he spends the rest, and the rest is going to be 100. Take away 28. We know percentage is out of 100. Now, if you've got more on the floor, borrow from next door. I can't borrow from that 0, so I'm going to have to borrow from here. Make that a 10. Then borrow from there, make it a 9 and make that 10. 10 take 8 is 2. 9 take 2 is 7. So he spends 72%. For Harry, he spends, I'm going to put it over here, 3/4. Now, 3/4 is the same as 75%. So he saves 1/4, which is 25%. For Isabel, the amount she saves, the amount she spends is 3 to 7. Now I want to take the ratio 3 to 7 and I want to turn it into a percentage. We know percentage is out of 100. So I'm going to take 100% and I'm going to share it in the ratio 3 to 7. Now I like to do these little lines for ratio. 1, 2, 3, 4, 5, 6, 7. So I'm going to take my 100% and share it equally over these 10 lines. So 100% divided equally over 10 lines, because I've got 3 lines and I've got 7 lines, is 10. So I've got 10, 10, 10, 10, 10, 10, 10, 10, 10 and 10, which means that she is saving 30%, because that's all of those three lines together, and spending 70%, because that's all of those lines all together. So she's saving 30 and spending 70. The question is, work out who saves the most of their salary each month. So we're now looking of the savings. I've got 28, 25 and 30. So we can see, and we need to write a sentence. Isabel, actually just Isabel is sufficient, but I'll put Isabel saves the most. Whenever they ask you a question, you need to answer their question. Work out who, it wasn't a question, but a statement. Work out who saves the most of their salary each month. You must show how you get your answer. So all of that working, and we've said Isabel saves the most. Okay, question 16. We've got a bit more algebra, and we're doing some substitution here. It says P is 4x add 3y. So 4x means 4 lots of x, and 3y means 3 lots of y. It says x is 5 and y is -2. So to get P, I need to do 4 lots of x, but we know that x is 5, and I need to do 3 lots of -2. 4 lots of 5 is 20, and 3 lots of -2, when you're doing a positive times a negative, we just do 3 times 2, but then we make it negative if you've got one of each, and that's -6. So P is 20 add -6, and having both those symbols next to each other, that becomes a takeaway. So 20 take away 6 is 14. That is your value of P. Part B, expand. So when we expand the brackets, we're doing what's on the outside multiplied by the first thing, and what's on the outside multiplied by the second thing. So we are multiplying everything in the bracket by 4e. This means 4e lots of this bracket. So everything in the bracket needs to be times by 4e. 4e times e, this times this. When you times an e by another e, it becomes e squared. So that's 4e squared. And now I need to do 4e times 2. And that's going to be 8e. And that's positive, so we can put a plus in between. I can't add those two together. They're not like terms. One of them's an e squared and one of them's an e. So I can't make it 12 anything. It's 4e squared, add 8e as my final answer. And now we need to solve an equation. So when I solve equations, I like to put a dotted line where the equals is. And what we do to one side, we're going to do to the other. I'm going to start, though, by expanding out the bracket. So I'm going to do 3 lots of m and 3 lots of -4. So that's going to be 3m. And 3 times 4 is 12, so that's going to be -12. And that equals 21. Now, what has happened to m? M has been multiplied by 3, and then we've taken away 12 and got 21 as our answer. And I want to undo that. So I'm going to start, let me change colour for this, by adding 12 to both sides. That's going to get rid of my -12. So 3m is all I'd be left with on the left-hand side, equals 33, because I'm doing 21 add 12. Next, if I've got 3 lots of m, but I just want to know what m is, I'm going to do the opposite of timesing by 3, and I'm going to divide by 3, and that's going to get rid of the 3 and just say that we've got m. We've now just got 1 lot of m, and that equals 11. So m is 11. You can always check your answer by putting 11 in here. 11 take away 4 is 7, and 3 lots of 7 is 21. So yes, that works, it makes sense, and we're happy with our answer. Okay, question number 18. Set A is the multiples of 5 between 14 and 26. So these curly brackets just mean a little set of numbers that are defined by that rule. So the multiples of 5 are all the numbers in the 5 times table, but we only want the ones between 14 and 26. So I'm just going to write them here. So we could write this as 15, that's in the 5 times table, 20 and 25. We can't go any higher because they only want the numbers in the 5 times table, the multiples of 5 between 14 and 26. For B, we want the odd numbers between 14 and 26. So the odd numbers would be 15, 17, 19, 21, 23 and 25. Can't go up to 27 because that'll go over 26. And that's all the odd numbers, all the numbers not in the 2 times table. So that's your A and that's your B. Now I could put that information in a Venn diagram. So sometimes on GCSE questions, we're then asked to fill out a Venn diagram like this, with one circle being A and one circle being B. And in A, I've got 15, 20 and 25. And in B, I've got 15, 17, 19, 21, 23 and 25. So the 15 and the 25 are in both. So we could put those numbers in the intersection, which is the middle bit. I'd have 20 left out here, and that makes my A circle complete. And I'd have 17, 19, 21 and 23 left in B, and that would make that circle complete. And then you can be asked 2 things. You can be asked for this, which is called the union. So A union B is any numbers in either A or B. So if you imagine you have your 2 circles, you can select anything that's in any of the sections going across. If you're asked for A intersection B, then you're only allowed to pick numbers that are in that intersection, in that middle section. So how I remember that, I think this shape looks a little bit like those grabbers from the grabber machine. It's very picky. It's only going to pick it up if it's in the middle. And this one, I think, wow, that looks like a big bucket. So we'll just scoop all of the numbers into that one. It's a bit silly, but it's how I remember it. So for this question, if we want A union B, we don't mind any of the numbers. So we can have 15, I'm going to put them in order, 17, 19, 20, 21, 23 or 25. So any of the numbers in either A or B for the union. Describe the members of A intersection B. So remember this one, to be in this little set, they have to be in both. So we're going to say odd multiples of 5 between 14 and 26, and we could also just say that that is 15 and 25, like that. That is the members of that club, all done, of that set. Question number 20. In a village, the number of houses and the number of flats are in the ratio 7:4. So we've got houses to flats in the ratio 7:4. So for every 7 houses, there are 4 flats. The number of flats and the number of bungalows are in the ratio 8:5. There are 50 bungalows in the village. How many houses are there in the village? Okay, so 50 bungalows. So we want this number to be 50. We know that for every 5 bungalows, there are 8 flats. So if there are 50 bungalows, there must be 80 flats. Okay, but for every 4 flats, there are 7 houses. So if for every 4 flats there are 7 houses, I need to know if there are 80 flats, how many times bigger have I made that? And it's been timesed by 20. So if I times one side of a ratio by 20, I've also got to times the other side by 20. So I need to times the number of houses by 20. So 7 times 20, I can just do 7 times 2, which is 14, and make it 10 times bigger, so 140. So the ratio of houses to flats to bungalows is 140 to 80 to 50, and so how many houses are there in the village? That would be 140. Looks really complicated, that question, but if you just keep working with the numbers, it does come out quite nicely. Question 22. A cycle race across America is 3,069.25 miles in length. Juan knows his average speed for his previous races is 15.12 miles per hour. For the next race across America, he'll cycle 8 hours per day. Estimate how many days Juan will take to complete the race. So when we're estimating on the non-calculator paper, we normally want to round everything to one significant figure. So we want to say that the cycle race is 3,000 miles long. And we want to say that he can go. Now, the mark scheme actually allows 15 or 20 for this. So 15 or 20 miles an hour. 20 would be one significant figure. That would be rounding to one significant figure, but 15 was allowed in the mark scheme here as well. And then we've got 8 hours a day. So if he cycles, I'm going to use, which one shall I use? I'll use 15 for this. So 15, but if you use 20, don't worry, you'd still get full marks. So if he can do 15 miles per hour and he's going to cycle for 8 hours a day, 15 times 8, I'm going to do 10 lots of 8, which is 80. 5 lots of 8, which is 40, and add it together. So that's 120 miles per day that he can do. How many days is it going to take him? Well, we need to do 3,000, and we need to divide that by 120. Now, if you get a tricky division and you're not sure how to do it, write it as a fraction, and then just keep simplifying. So I'm going to do divide the top by 10, divide the bottom by 10. So that'd be 300 divided by 12. I'm now going to divide that by 2. So that's 150 divided by 6. They're both in the 3 times table. So I'm going to make that 50 over 2. And that would be 25. So I'm going to say roughly 25. But if you did it with 20, don't worry, you also would have got the marks. Okay, so Juan trains for the race. The average speed he can cycle at increases. So because he's trained, he can now cycle more miles every hour. How does this affect your answer to part A? Well, if he can cycle more miles every hour, it's going to take him less days. So it will take less days. If he's going quicker, it will take him less days to finish the race. So it will take less days. Your answer to part A will go down. Okay, question number 24. A pattern is made from 4 identical squares. The patterns of the sides of the squares, are parallel to the axes. Point A has coordinates 6, 7. Point B has coordinates 38, 36. And point C is marked on the diagram, but we don't know where that is. Work out the coordinates of that point C. Okay, so looking at this, I can see that I've got 4 squares. Now going across, I've got 1, and then the next one starts 2, and then the next one starts 3, and then the next one starts 4. So I've got 4 squares going across, but going up, we've got this slight overlap here, so that'll be a bit trickier. But going across, we can see that the X direction, remember along the corridor up the stairs, this first number is how much across we are. So we've started on 6, and we've ended on 38. So that is 32 going across in total. So that width there, it's gone across by 32 because we've started on 6 and we've ended on 38. Now, if 4 squares are 32 wide, if I do 32 divided by 4, I know it's going to be 8, 8, 8, and 8. So these are all squares that are 8 wide. So we know to get to C, I've gone across by 2. So I've got to go 8 across and another 8 across. So for the coordinate of C, I know that this first number, I can take the 6, I can add 8 to it, and add another 8 to it, and that will tell me how far across I am. So 8 add 8 is 16. If we add that onto 6, we get 22. So that's that direction. Now with the going up, because these are squares, if they're 8 wide, they also must be 8 tall. But I know that this is 8 tall, but I don't know how far up to go to get to that bit. But if you look from above, it is a whole square, a whole 2 squares down from this value. Okay, so your second number of each coordinate is how far up or down we are. And I'm going to start at 36. If I come down 8 from 36, I get to 28. If I come down another 8, I'm going to get to this point here, and that's going to be 20. So your answer to that is 22, 20. Quite a tricky question. So well done if you got that. And last but not least, question number 26, and we've got work out 2a add b as a column vector. Now column vectors are instructions. They tell us what to do. A tells us to go 5 to the right and then 2 up. The top number is left and right. The bottom number is up and down. If it's positive, it goes up. Negative, it goes down. Positive, it goes right. And negative, it goes left. So 5, 2 goes 5 right and 2 up. And for vector B, it goes 1 left and then 7 up. Okay, that's what it does. If I want 2 A's, I need to go 5 right, 2 up, and then another 5 right and 2 up. So I need to double it. And then I need to add on -1, 7. Now, these are not fractions, so you can just add them, okay? So 2 lots of 5, 2, that's going to be 10, 4. Instead of going 5 across and 2 up, I'm doing it twice, so I'm going 10 across and 4 up. And then I've got to add on -1 and 7. And so 10 add -1 is 9 to the right, because I'm going 10 right and then 1 left. And then 4 up and 7 up means I'm going 11 up overall. And that is your final answer. That's 44 marks. Well done if you stayed with me until the end of the paper. Remember that the next one will be out next week, and you can go through this one with me live on TikTok on Thursday. I hope that helps. Bye.